Hey guys, Miss Miklos here, and today we are going to be talking about solving linear systems by what we call Cramer's rule. And I'm calling this section 3.4. However, in the book, it is in a completely different chapter. In fact, this may be your first foray into matrices. Today we are going to be dealing with matrices, but if you have no clue what those are other than the plural of matrix, and you know that that's a movie with Keanu Reeves, you're fine, okay? You guys will get a lot more in-depth in matrices in pre-calculus. The advantages for this particular method is that it's very systematic. In fact, we don't really need to think that much. We're going to be following the same steps every single time. And fractional answers are not a problem. The reason being, they don't come up until our final answer. It is also really easy to use if it is written in standard form. Our biggest disadvantage is if the problem is not written in standard form. So let's go ahead and look at this for a second. And you guys may be noticing my friend over here. He's a fish. In fact, his name is Mr. Determinfish, and in class you guys can meet him in person. But you guys will kind of understand why Mr. Determinfish is here to help us. And his favorite thing to say is, subtract, baby. And we're going to be saying that a lot, so to make myself feel better, it might be nice if you guys said that aloud by yourself at home while you're watching this, while I say it. And it's dumb, but it honestly will help you remember how to do this. Okay, so if we are looking at example number 1 here, we are going to start by making what we call a determinant. And in fact, in our determinant, we are going to do something very specific. My first column in my determinant are going to be our x coefficients. So in this case, that would be 3 and 4. My second column are going to be my y coefficients, which in this case are -4 and -7. Okay, so that's the very first step in setting up determinant D, putting our x coefficients in our first column, our y coefficients in our second column. Now, we are going to start in the top left-hand corner, and I am going to multiply down across our diagonal. So what I mean by that, I'm starting up here and I'm going to do 3 times -7. So I'm going to write out 3 times -7. At this point, Mr. Determinfish tells us, subtract, baby. So I need to remember to put a minus sign, and then I'm going to multiply -4 times 4. So, Mr. Determinfish, oh, do we see the fish? Like a Jesus fish. Okay, it's really cheesy, but it helps us remember. We always start in the top left-hand corner, multiply down, subtract, multiply down. So in this case, I get -21 minus -16, which becomes -5. Okay, 1 down, 2 determinants to go. So our next determinant is what we call d sub x. Okay, and what we're really going to be paying attention to here is this x. Since we're trying to find d sub x, that means I'm replacing this x column with the constants. Remember, constants are numbers that are all by themselves. Okay, and in this case, they are set equal to, or they're like the c value in standard form. My second column is going to remain my y column. So my first column is 6, 8. My second column is -4, -7. Once again, I'm going to start in the top left-hand corner. 6 times -7. And if you guys were just writing out the value instead of writing out the math, that's okay. At this point, Mr. Determinfish says, subtract, baby. -4 times 8. So I have negative 42 minus negative 32, which becomes negative 10. Last but not least, I have d sub y. Y means that I'm going to replace my y column with my constants. My first column is going to be our x coefficients again. Okay, so d sub x means I replace my x column. D sub y means I replace my y column. Now the fun's going to begin because we're going to start at the top left-hand corner. 3 times 8. So 3 times 8. And Mr. Determifish says, I can't hear you. Subtract, baby. 6 times 4. So I have 24 minus 24, which is 0. Now at this point you might be thinking, okay, yeah, this is not difficult, it's a little time consuming and weird, but it doesn't really look like we got answers because we know our answers should be in ordered pair. So we need to know that the way that we find our solution is by doing d sub x divided by d sub y divided by d. So to find our answer, we're going to take d sub x, which was negative 10, so I'm going to write x equals negative 10, divided by our d value, which was negative 5, which gives us an x value of 2. So I know my x value is 2. To find my y value, I'm going to do d sub y, which is 0, divided by d, which was negative 5. 0 divided by negative 5 is 0. So I end up getting 2, 0 as my solution. One thing that I just want to point out, when we're doing d sub x divided by d and d sub y divided by d, an easy way to remember this, even though mathematically this is not accurate, it's like if I cross off the d's, I'm left with x. So this is my x value. If I cross off these d's, I'm left with y. So that is our y value. As in every other section this chapter, I can take 2, 0 and substitute it into these two equations to double check if they work. So let's do that real quickly. I would get 6 minus 0 is 6, which is true. And 8 minus 0 is 8, which is also true. So I know that that is an accurate solution. So moving on, for some reason I skipped number 2 on this, so number 3 is really number 2. And we are going to use Cramer's rule here, so I'm going to start by finding our D determinant. Just a reminder, my first column are our x coefficients, 3 and 5. My second column are our y coefficients of negative 4 and negative 8. This time I'm going to do some work in my head, okay? But as I go through this, just a reminder, I always start in my top left-hand corner. 3 times negative 8 is negative 24. Mr. Determifish says, subtract, baby. Negative 4 times 5 is negative 20. I know negative 24 plus 20 is negative 4. Okay, next thing I'm finding here is going to be d sub x. And we said last time with d sub x, what we're going to do is replace x with our constants. Okay, so I have 7 and 9. My y column is staying exactly the same with negative 4 and negative 8. I'm starting in the top left-hand corner. 7 times negative 8 is negative 56. Mr. Determifish tells us, subtract, baby. Negative 4 times 9 is negative 36. So I end up getting negative 20. Last but not least, I need to find d sub y here. This time, I know that my y column is being replaced with our constants, and my x column is going to be our x coefficients again, so 3 and 5. When we start in the top left-hand corner, 3 times 9 is 27. Mr. Determifish says, subtract, baby. 7 times 5 is 35. 27 minus 35 is negative 8. So now I need to go ahead and figure out what our answers are. To find x, I'm doing d sub x divided by d. So I have negative 20 divided by negative 4, which is 5. My y value is d sub y divided by d, which would be negative 8 divided by negative 4, which is 2. So that's telling me that 5, 2 is my solution here. If I go back and look at my original problem, let's just double check if 5, 2 works. Okay, I get 15 minus 8 is 7. That is true. 25 minus 16 is 9, which is also true. I think this is definitely one of those concepts that the more we do it, the easier it gets and the better we get at it. So we're going to do number 3 here. We need to find determinant D. In fact, if you want to test how you're doing on your own, it might be a good idea to pause the video and find D, D sub x, D sub y on your own, and then start up again and see how you're doing. So for D, I know my first column are negative 7 and 5. Those are my x coefficients. My y coefficients are 4 and negative 2. A word of caution, I know the biggest mistake I make is forgetting these negatives. So before we even get going, just double check that you wrote everything correctly. Negative 7 times negative 2 is 14. Mr. Determifish says, subtract, baby. 4 times 5 is 20, so I get negative 6. D sub x. This time I replaced our x column with our constants, which were negative 5 and 3. My y column stays the same. Negative 5 times negative 2 is 10. Mr. Determifish says, subtract, baby. 4 times 3 is 12, so I get negative 2. Last but not least, d sub y. So I know my first column now are going to be our x coefficients again. My second column are the constants, so those were negative 5 and 3. When we start in the top left-hand corner, negative 7 times 3 is negative 21. Mr. Determifish says, subtract, baby. Negative 5 times 5 is negative 25, so I end up getting positive 4 as my answer. Now based on these, let's find our answers. X is d sub x divided by d, which is 1/3. Our y value is d sub y divided by d, which becomes negative 2/3. So that gives us 1/3, negative 2/3 as our solution. This is a really good example as to why Cramer's rule can be helpful when we have fractions as our answers, because I didn't have to go ahead and do any operations with fractions. In fact, if I really wanted to avoid it, when I'm double checking, I could just put this in my calculator, okay? But I know that we are all math studs, so I'm going to go ahead and do this. When I substitute in, I get negative 7/3 minus 8/3, which is negative 5. That works. Okay, when I substitute into the other one, I get 5/3 plus 4/3, which indeed is 3. So it just shows me it does work in both equations. Now, some of you might be thinking, okay, this is great and all, and it's my new favorite thing to do, not just in math, but in life. But what about our strange solutions when we get no solution or a lot of solutions? So let's look at number 5. Okay, if I'm setting up D, I would get 3, 6, 7, 14. I know 3 times 14 is 42. Mr. Determifish says, subtract, baby. 7 times 6 is 42. So I end up getting 0. This gives us a major problem because we know we cannot divide by 0. So, since in order to find x and y, I do d sub x divided by d, it's not going to give us an answer. So we know the only two options are that our lines are parallel or we have the same line. So what we're going to have to do here is look back at our original equations and figure out, are they the same line? Okay, if they are the same line, then we know our answer is going to be the ordered pair x, y on, and then write the equation of the line. If they're not the same line, that means that they are parallel, and that means that we have no solution. We know the same line has the same the same slope, the same y-intercept. An easy way to double check this is to look and see, can I multiply one of these rows by a constant and get the other row exactly? What I mean by that, if I look at this first row, I'm thinking to multiply it by 2. When I multiply it by 2, I get 6x plus 14y equals 20. Since these two are not exactly the same, okay, because of these numbers right here, that tells me they are actually parallel lines. If we wanted to be more exact, I could find the slope and I could find the y-intercept, but we don't have to do that much work. If I end up getting the same exact equations, then I know it's the same line. So in this particular problem, my answer would be no solution. Okay, and on to our final system, and at this point, you guys should know subtract, baby, because I've said it like 15 times. So, let's go ahead and start with D. So I would have 3, 6, and 7, 14. So when I go through this, 3 times 14 is 42, and everybody says, subtract, baby. 7 times 6 is 42. So I end up getting 0, which once again we know is a major problem. So I'm going to look at these two equations. This time, I'm going to multiply this top equation by 2, and it gives me 6x plus 14y equals 20. This time, these are exactly the same. So that means my answer is all the ordered pairs on the equation of the line, 3x plus 7y equals 10. Now, if you guys figured this out just by looking at these equations, I would not require that you do any of this work. Okay, however, if we ever get 0 as our determinant, that should be a signal that I can stop. I don't need to find d sub x, d sub y, look back at the problem, and figure out, is it all these answers or is it no solution? The final few problems here are going to seem very simple now that we've gone through solving systems. It's just telling us to evaluate. So we're just going to use Cramer's rule, or really Cramer's rule is how we solve the system. Here we're just evaluating a determinant. So I'm going to do 3 times 4, which is 12. Mr. Determifish says, subtract, baby. K times K is K squared. In this case, I can't combine those. Those are not like terms. We definitely could go ahead and write it in descending order as negative K squared plus 12, but I would accept either of these answers as our final solution. Number 2. 6 times negative 5 is negative 30. Mr. Determifish says, subtract, baby. Negative 2 times 2 is negative 4. Negative 30 plus 4 becomes negative 26. And our final problem of the day. Yay, we have binomials. X minus 4 times x plus 4. I'm actually going to write that out to save me some time here because I don't want to make a mistake in my head. Mr. Determifish says, subtract, baby. Negative 3 times 5 is negative 15. I know that when I'm multiplying two binomials together, I need to FOIL. So I'm going to go ahead and multiply this together. And we may notice in this that my inside and my outside terms cancel each other out. So when I combine my like terms, I get x squared. These cancel out. I can add negative 16 plus 15, and I get minus 1. Now, for those of you who love to factor, and I know we haven't learned that yet this year, but you learned it last year, or I should say 2 years ago. Yes, this is factorable, but I don't need to do anything else with it. We just need to make sure it's simplified and all my like terms are added together. So, this was a quick video on how to use Cramer's rule and how to evaluate determinants. Soon, they may become one of your favorite methods in math.